Well, all right, guys. Welcome back, man. Welcome back to Herbs class. Glad you came back for these practice problems because that binomial distribution, man, is a killer until you get to the practice. All right. So first thing we got to check is that this situation obeys the rules. Is there a chance of success and a chance of failure? Every time Nathan shoots a free throw, he's either going to make it or he's going to miss it. Sounds good to me. All right. Now, does his probability change with each free throw? No. It says he's a 60% free throw shooter, so that means that the probability every time he shoots that he's going to make it is 60%. All right. So far, so good. And now, are there a limited number of trials? How many free throws we talk about shooting? 12. Yeah. All right. So we're good. A couple of things we're always going to need to know, right? These three things, actually. Every binomial probability question that you come across, you're going to need to know these three things. Trials. How many times are we going to do the thing? For this particular problem, how many free throws are we talking about shooting altogether? 12. Yeah, exactly right. And what's the probability on each free throw that I'm going to be successful? Yeah, exactly right. Don't forget to change that percentage to a probability. So 0.6, good. And now how many successes am I talking about? Ooh, key word here. Exactly. 10. Yeah. All right. So I'm going to show you what that exactly 10 means when we break out the calculators. Now, as you can see, I have a TI on the left and I have a Casio on the right. I'm going to show you how to enter this information into both. Believe me, the math that it would take to get this done without the calculator is going to take you a long time and a lot of headaches. So best to just put it into the calculator. All right. So let's turn them on. All right, so on a TI, you're going to hit second vars, which has the distribution above, because we want distributions. And I'm going to go down until I see binomial. Now, when I get there, notice that there are two binomials here. I have a binomial PDF and a binomial CDF. Binomial PDF is when you're looking for the probability for an exact number. Think PDF like P for precise. When it says exactly a number, if you want to know the probability for that exact amount of success, you would use PDF. Exactly right. Now, CDF is for a cumulative range of probabilities. So we'll get to that in a minute. PDF is for precise, exact number. That's what we're looking at. That's what we're looking for. So I'm going to go ahead and choose that. Now, your newer TIs, it'll give you a table for you to fill in these very numbers. And if you have an older TI, it's going to give you a command line. These are the numbers you put in. 12 trials, 0.6 probability on each trial, and I'm looking for the probability for 10 successes. So 12, separate these numbers with a comma, 0.6, comma, 10. Close parentheses, enter. Bang, that's my probability. Yeah, turns out Nathan has about a 6% chance of making exactly 10 free throws if he shoots 12. Now let's talk about how to do that on the Casio. All right, so on the Casio, you're going to hit the menu button and go ahead over to statistics because that's what we're working on. Distribution is down here, P5, all the way to the right. So I'm going to hit the function button under binomial, BINM. As you can see here, we have binomial PDF, binomial CDF. And we just talked about this problem would be a PDF. Good. All right. Now, your Casio is set up a little bit differently. The things are in a different order. So make sure this is on variable and not list. You don't want list. You want variable for your data. X is the number of successes. So I'm going to put in 10 here because I want to know if it's exactly 10 free throws. Enter. The number of trials we talked about is 12. And that lowercase p is the probability of 0.6. Execute, execute. And there you see we have the same probability. Nice. So that's how we use the binomial probability function on your calculator to find an exact number of successes. What if we need to know a little bit more than that? Okay, problem number 2. Now, problem number 2 reads a little bit similarly, but as you can tell, hopefully if you read pretty closely, you came up with the difference here. At most 10. No longer does it say exactly. So we're not going to be using PDF because remember, PDF is for an exact number of successes. So here, we're going to use the other one, CDF. And think C as in it's a cumulative probability of all numbers up to and including your value of success. So this is what I mean by this. So trials stay the same, 12. Probability stays the same, 0.6. But now our successes is worded a little bit differently. Before it was exactly 10. Now it's saying at most 10. So what does that mean? What number of made free throws are we talking about? At most 10 means 10 and below. So we're talking about what's the probability of him making 1 free throw, 2 free throws, 3 free throws, any number up to 10. And now luckily for us, that's exactly the way that CDF is set up. When you do my binomial probability for CDF, it adds up all of the probabilities up to and including that number of successes. So up to 10. So when I go on my calculator, second vars down to binomial CDF now, I put in the same numbers, 12, comma, 0.6, comma, 10. But since this is using the CDF, this is going to give you the cumulative probability of all successes up to and including 10. So now when I hit enter, I'm going to get a much higher number. There's a 98% chance that he is going to hit up to 10 free throws if he shoots 12. Nice. Same thing on the Casio. I'm going back to stat, back to distribution and binomial, but at this time I'm going to hit CDF. Exactly right. Same values that we have entered, but remember CDF executes a little bit differently. Nice. Let's kick it up a notch. Okay, 3 reads the same to me. Uh-oh, wait a minute, less than 10. If you haven't figured this out yet, man, wording is super duper important here. So less than 10. All right, let's see what that means for our problem. So are we talking about an exact value? Nope, we're talking about a range. So that is CDF, exactly right. Number of trials, 12, of course. Probability, 0.6, same. Talk about the same dude, man. 60% free throw shooter, which is not very good, by the way. Anyway, so now let's talk successes. Less than 10. Does less than 10 include the number 10? No. So how many successes am I talking about? 9 and below? Yeah, and remember CDF gives you the probability for that number of successes and below. All right, so now we're talking about 9 successes, and all it took was a little bit of a wording change. So entering that information into my calculator with 9 successes, I would get a probability of 0.917. And as you can see, that's slightly below what we were before, but remember, the last problem included making 10. So this one went up to making 9. Nice. One last one. Let's see if we really got it. Okay, last one. Let's see if we got this. Reading. Okay. Ooh. Uh-oh. That says more than 10. I thought, well, our CDF does only numbers and below. So how can we do more than 10? Wait a minute. I got an idea. All right, let's fill this out. Trials, 12. Probability, 0.6. Okay, so far so good. Now, if my CDF cannot do successes and above, can I take the probability for those successes and below that I do get and just subtract that probability from 1? Oh, yeah. All right, so let's find the probability that he makes 10 or below, because that's what CDF can give us. So this is a 2-step problem then. The probability that he makes 10 free throws or less is 0.98. So if I want to find out the probability that he makes more than 10, can I just subtract that probability from 1? Oh yeah, bang. So moral of the story here is CDF gives you the probability of that number of successes and below. If you want to find a probability of more than that number of successes, you got to subtract it from 1. Good job, guys. All right, we're going to practice this some more, but good. I hope this started you off. Thanks for coming checking me out, man. I'll see y'all next time. Bye.